coatings for food protection. So what's relevant or what's the point of my project? Today we are producing over 380 million of tons of plastic every year, and some reports indicate that up to 15% of which is for single-use purposes. So reducing this vast number is a priority in the fight against plastic pollution. Additionally, food waste is also a relevant problem for all countries over the globe, whether it's highly developed country or not. So finding good packaging material is relevant and needed. The aim of the work was to evaluate the possibility of application there. Pullulan coatings based on yeast-like fungus Arabidopsis pullulans. Objectives of the work are to assess the antifungal activity of the culture fluid of the yeast-like fungus Arabidopsis pullulans in vitro and in vivo, to obtain pullulan films and determine the possibility of their application to preserve the quality and increase the shelf life of fresh berries, as well as to protect against phytopathogenic fungi. In order to find packaging systems capable of suppressing microbial spoilage and prolonging shelf life of the product, the microbial properties of the culture fluid were evaluated. Antifungal activity was determined against the test fluid of the phytopathogen through in vivo and in vitro. In vitro antifungal activity was determined by placing botrytis cineremedia suspension on a microscope slide and adding yeast culture with different cultivation periods. It was shown that Canidia germination and growth of the phytopathogen colonies were suppressed by culture fluid of pullulans. After 72-hour cultivation, all experimental variants showed sign of inhibition, expressed as significant reduction of Canidia, 50% to 25%. To determine the antifungal activity, Arabidopsis pullulans T7 cell filtrates were applied to fruits previously inoculated with suspension of Botrytis cineremedia Canidia. Disease severity assessed by lesion diameter was significantly reduced by culture filtrates of strain C7. When treated with 72-hour filtrate, this index was nearly 3.7 millimeters. The obtained pullulan films were used to improve the quality characteristics of strawberries during storage. For this purpose, strawberry samples were immersed in a pullulan solution with gelatin and glycerol and air-dried. The treated samples had a longer shelf life and retained color and brightness compared to the control. Study on the possibility of using pullulan coatings to protect food products led to following conclusions. First, the inhibitory effect of the Arabidopsis pullulans culture fluid metabolites on the growth of the phytopathogen Botrytis cinerea in vitro was shown. The number of germinated Canidia was reduced by 34% and germ tube by 25% after 72 hours of cultivation. Evaluation of antifungal activity in vivo showed that the diameter of berry lesions was reduced by 35% by Arabidopsis pullulans culture filtrates. And last one, food films coatings based on 1.2 pullulan solution and 0.3% glycerol and gelatin solutions were obtained. It was shown that pullulan coatings provides reduction of strawberry weight loss by 20% and increase of its shelf life up to 10 days. That's it. Thank you for your attention and for your time.